This video is all about how to place data into rank order. Non-parametric tests which use ordinal data such as Spearman's Row, Wilcoxon, Mann-Whitney U-test all require that raw data is placed in rank order. After all, ordinal data simply means data that can be placed in rank order. One question that students often ask is, should data be sorted from lowest to highest or highest to lowest? And the answer is, it really depends on what the data is. So for example, if you've got test scores and you're looking at the percentage that someone got on a test, then the highest value would get the rank of 1 first, because a higher score is more preferable. But if we were looking at the time taken to run 100 metres, then the smallest time is obviously the quickest. So the lowest value would get a rank of 1, in other words, in first place. So let's have a look at an example now to see how to do it. Let's imagine that we'd collected data from a 100-metre race and we'd got the following times in seconds. The first thing we need to do is to put them into order. And in this case, we want the lowest value first. So we want, for instance, 9.6 will get the value of 1. And the highest value, which is 12.5, will get the value of 10. So if we put them in a table like this, 9.6, 10.1, 10.5 and so on. And then underneath we can write the rank values of first, second, third, 4th, 5th, 6th, 7th, 8th, 9th, 10th, etc. So far, so easy. Really simple example there. Things get a little bit more complicated when there are shared or tied ranks. So let's have a look at another example here. So let's imagine I asked a group of students to rate Ed Sheeran's music on a scale of 1 to 10. 1 meaning you absolutely hate it and 10 being you love it. And these were my results. So we've got 5, 6, 4, 1, 1, 1, 10, 9, 8, 8. As in the previous example, the first step is to arrange in order, but this time from highest to lowest, because obviously we want a score of 10 to have the first place. So just as before, we put them into order. So we've got 10, 9, 8, 8, 6, 5, 4, 1, 1, 1. We can put our ranks underneath, but if you look at the highlights, you can see we've got a bit of an issue here because we've got shared or tied ranks. So 2 of my students rated Ed Sheeran's music as an 8, which gave them the rank positions of 3 and 4. Now, they can't have different values because they're the same. So we take the value in the middle. So they both become 3.5 because the middle value between 3 and 4 is 3.5. Note what happens to the next one though. After 3.5, the next rank is 5, not 4, because you've already used the rank value of 3 and 4, and 3.5 is in the middle. So the next one becomes 5. If we then look at the other extreme, we can see we've got 3 scores of 1. So these share the ranks of 8, 9 and 10. And in this case, the middle value is 9. So they all get the rank value of 9. So just some final tips on ranking data. Make sure you take your time when you do this and double check your ranking. This is the place where errors are often made in inferential testing of non-parametric tests. The ranking, if you've got it wrong, it's going to throw everything else out. So please do take your time. I hope you found that useful.